Question number 28. Which of the following has an acceleration of 5 meter per second? So a bicycle, when it speeds from rest means its initial velocity is 0 and final velocity is 2.5. So 2.5 minus 0 and in 2 seconds means divided by 2. So you can write it like this: 2.5 minus 0 and divided by 2, and it will give you 1.25. So in next part you can see a car, when it changes from rest to 15 meter per second, it means in this case it would be 15 minus 0 and it would be divided by 5, it will give you 3. Next is a lorry, when it speeds from rest to 20, it means this time it would be 20 minus 0 divided by 15 and it will be equal to 1.3. Next is when it speeds up from 0 to 50, it means this time it would be 50 minus 0 and it would be divided with 10 and we are left with 5. So the demand of the question was like which vehicle has an acceleration of 5 meter per second. So here is 5 meter per second, so you can see that the last one has the answer of 5 meter per second and the correct answer is D. So this is our correct answer. Okay. Oh, next question is, the graph shows a journey made by a cyclist. Okay, so you can see its initial velocity is 4, when time was 0, and 2, 3, 4, 5. I think here it would be 5, here would be 2, then it would be 3, then it would be 4, it would be 5, 6, 7. Okay, so the journey is for 7 seconds. Okay, how far did the cyclist travel in 7 seconds? It means we need to calculate the calculate area under the graph. So here is a rectangle, like this one is our rectangle and this would be our trapezium. Okay, so we are going to apply area of trapezium here and area of rectangle here. So area of rectangle, for area of rectangle I think so 2, 3, 4, 5, this one is 5, it represents 5 and here is 7. Okay, so area of rectangle is length into breadth, 4 times 7, so it would be 4 times 7, which would be equal to 28. And it is trapezium, the lower one is trapezium. Trapezium is 1 over 2 sum of parallel sides. Parallel side is the green one plus the blue one. So green is 4 and the blue one is 6. So 4 plus 6 multiplied height. Height is actually the line which connect two parallel lines, 5 to 7. So it is 2 and divided by 2. So 2 is cancelled with 2. So this 2 and this 2 are cancelled. We are left with only 6 plus 4 and it would be equal to 10. So this area is 10 and this area is 28. So one area is 10, the other one is 28. So total area is there any mistake? Oh, area of rectangle. Oh, sorry. It's not 7, it's 5. So I made a mistake here. So it would be 12. So now rectangle, area of rectangle is 20 and area of trapezium is 10. So total area is 30. So the correct answer is B. So this is our correct option. So in question number 30, it is related with terminal velocity. Again a terminal velocity question. Okay, it says the diagram shows a parachutist is in 4 position after she jumps from a high balloon. At which position does she have terminal velocity? We are going to find out the position where it will have terminal velocity. So the terminal velocity position is, okay, so you can see not yet moving. When it is not moving, it means it has no velocity. When there is no velocity, then it means there is no terminal velocity. When object is in rest, so we can't say whether its velocity is terminal or not. Object is in rest, in state of rest means no velocity. No velocity means not a terminal velocity. Okay, terminal velocity is actually a constant velocity. So option B, it states it is accelerating. The object only accelerate when the velocity changes, but terminal velocity is a constant velocity. So it's also incorrect. Okay, not accelerating. Not accelerating means object is moving with constant velocity. So it may be a correct option. The next one is object is not moving. When object is not moving, it means the object has no velocity. When there is no velocity, then we can't say that there might be some terminal or any other velocity. So this option is also incorrect. Okay, so we are left with only one correct option, which is C. So our D option is also incorrect. two men jump out of an aeroplane at the same time. One of the men opens his parachute and the other one remains in free fall. So this guy hasn't opened its parachute, and this and is under free fall, and this one has opened its parachute. So it is yeah, like this. So it has opened and it doesn't. So you can see, you can just compare their locations. So you can see the person without parachute is leading the person who is who has opened its parachute. So let's compare them. Why is the man in free fall moving faster than parachutist? So this guy is leading this one, and what is the main reason behind it? So you can see, like the parachutist has more surface area, so it will experience more friction force. Its surface area is small, it will experience less friction force. So the person with parachute will reach terminal velocity quickly, and this guy will reach terminal velocity after a very large time. So let's see. So the man in free fall means this guy experience greater air resistance. No, its surface area is small, it will experience less air resistance. The man in free fall has greater mass. No. Okay, the parachutist experience greater air resistance, correct, because its surface area is large. The parachutist has not reached the terminal velocity. No, that's incorrect. So we have C as correct option. So let's move to the next one. 32. In 32 it says a student measures the speed of a trolley. At one instant the speed of the trolley is 1 meter per second, and 2 seconds later the speed is 4 meter per second. Okay, so it means this is U, and this is V, and 2 seconds means it's time. So U is 1 meter per second, V is 4 meter per second, and T is 2 seconds. What is the acceleration of the trolley? So we know the formula of acceleration, U minus V over T, or V minus U over T. So V is 4 minus 1 divided by 2 seconds. So it comes out 1.5 meter per second square. So the correct option looks this one. So our correct option is this one. So these are incorrect options. Okay, so let's move to the next one. Number 33. The speed time graph shows the movement of a car. What does the shaded area of graph represents? So we know that in case of velocity time graph, area under the graph actually represents the distance traveled by the object. So the speed time graph, here is a speed, here is a time, and it's a speed time graph. And area of shaded area, actually area under the graph represents the distance traveled by the object. Let's check the possible options. Okay, the average acceleration of the graph, nope. The average speed of the car, nope. The total traveling time of the car, nope. So we have C, which is the total distance traveled by the car. Okay, so let's move to next one. The small stone, a small stone is okay. A small stone is dropped from the top of a ladder, falls and hits the ground. It does not rebound. Which time graph is correct? So when a stone falls, suppose this is a stone, falls from the top of a ladder. Initially its velocity is suppose 0 when it was in state of rest. With the passage of time its velocity increases, and suppose here is a ground, where it strikes with this surface and does not rebound. It means at this point, like just before it hits the ground, it will have maximum velocity, but once it strikes with the surface it comes to rest. So it means like when it was falling, it will have a graph like this going in upward direction, but at the same time, at the same moment, its velocity fall to 0 like this. So let's compare the options. So like our possible graph is this one. So option A, B, like see why option A is incorrect. Okay, the graph till here looks fine, but see after this its velocity is constant. It means suppose its velocity is 10 here and it is 10 here, it is 10 here, 10 here, 10 here, and so on. But the question says that its velocity, like it came to rest state, it means its velocity will become 0 at this point. Okay, so let's see why B is 0. B says that its velocity remains constant. No, when it was here, suppose the stone was somewhere here, its velocity was 0. It says its velocity was something like suppose 10. Its velocity is 10, but initially when it was it fall from somewhere, its velocity was 0. So that's something incorrect. Then it means this portion of the graph is incorrect. it looks fine after this time, after this point it looks fine, but this portion of the graph is incorrect. Okay, let's see why D is also incorrect. And let's see why D is incorrect. It says like the stone has some initial velocity and then its velocity decreases. See, its velocity is decreasing, but actually when object falls its velocity increases. That's why this graph is incorrect. Now let's move to part C, and part C is actually similar to our expected graph. So why it is correct? See, it started from 0 and with the passage of time its velocity is increasing, and at this maximum time when it has maximum velocity and it strikes with ground surface, its velocity came to 0. So that's why it's correct. Let's move to number 32. A student oh sorry, it's not 32, it's 34, then 35. Okay. Okay, now in question number 35 it states that a student pulls a piece of tape. Here is a piece of tape, you can see, and the student pulls it through a ticker tape timer. Here is a ticker tape timer, like something is here, I don't know. Every 0.02 seconds the timer print a dot on the tape. Like you can see these are dots, like this is actually a tape, and upon which after 0.02 second there would be a dot printed on it. First the tape is pulled quickly, then slowly, then quickly again. So there are three different ways, three different stages. Tape is pulled quickly, okay. So let's see, here is a tape and it is slightly moving like this. Suppose it is slowly going like this. So when its speed is slow, then the dot printed on it would be, one would be here, one would be here, next would be here, like all of them would have equal spacing, because it will print a dot on it after 0.02 seconds. But if you quickly if you quickly pass it, then the distance between these dots will increase. One spot, one dot would be away from the other, like the distance between two consecutive dots would be large when it would be quickly passed through it, because the time is fixed and the tape will travel more distance than as compared to slower one. So the situation would be like this. So what is conclusion? Conclusion is the dots would be closer when the tape is moving slowly, and the dots would be away from each other when it is quickly passing through that machine, that particular machine. So we have three options. So look at these possible options. Tape is pulled quickly. It means when it is a quick area, then it means the spacing between them would be large. Then slowly means the dots would be close to each other. And the last one is quickly again. It means the dots would be away from each other. So it means we have two areas in which the dots would be away from each other, would have large spacing. This one have large spacing, this one will have large spacing, and in this case the middle one, the dots would be close to each other. So you can say the middle one will have spots which would be closer to each other, and the side ones would be away from each other. So let's match with our graph. So see, so when the dots are close to each other, it means this is slow region, so it represents slow. I'm gonna put S over here. So here the dots are further apart from each other. It means the particles are the tape is quickly passed in this region. Here we have slow area because particles are close to each other. Okay, so it actually does not match with our given options, so it is incorrect. So let's see the D1. In case of D, it looks that the particles are equally spaced from each other. It means the tape is the tape is passed through that particular machine with a constant speed. That's why it is incorrect. Look at this C. Initially it was slow, then its speed is increasing. Like you can see, the distance between these two is small, large, large, getting large, getting large, getting large. So the distance between the particles is increasing, so that's also incorrect. So we are left with only one option, which is let's match it. You can see the tape is pulled quickly. Quickly means this area, the particles are away from each other. Slowly particles are close to each other. Then quickly again particles are further apart from each other. So this option is our correct option.